So we just talked about how the chemoreceptors in the aortic arch and the carotid arch in the brain regulate blood flow systemically. But now we're going to talk about regulation of blood flow to the organs, and specifically autoregulation of blood flow to the organs. So it's another beautiful thing where each organ can sense its own blood, whether it's getting enough blood, and then tell the body to adjust accordingly. So first one is the heart. Remember, the heart's a big fat muscle, and a big fat muscle needs a lot of blood to give it energy and to remove all the waste products. So when that heart is beating and it's using all that energy, it's causing a lot of local metabolites and it's causing a lot of waste products. And if there's too much of it, it's gonna build up, and it's gonna be telling your body that, hey, I need more blood because I'm building up too much of this, and I'm not having enough blood to clear it all out. So there's going to be local metabolites, especially nitric oxide, adenosine, and carbon dioxide, and oxygen. And these are going to cause vasodilation of the coronary arteries. Remember, the arteries to the heart, supplying the blood to the heart, are the coronary arteries of it. Okay, and you're going to get vasodilation. Actually, I want to take a step back. I want to take a note that these are all controlled by metabolic factors, okay? And then we'll see what happens with the skin in a second. So the brain we just talked about. Remember what factors determine blood flow to the brain? What factors are going to increase blood flow? Remember, it's going to be it's carbon dioxide, and is it higher or low carbon dioxide? Remember, it's high carbon dioxide. That means there's buildup of carbon dioxide. It's not enough blood to get rid of it, okay? And then what happens to the pH if you have high carbon dioxide? When that pH will go low, so lower pH, these all cause increased blood flow, so vasodilation. And you're going to vasodilate to get more blood into the brain to get rid of all these waste products. Next one is the kidney. Kidney, there's a special system called the juxtaglomerular feedback system. So there's little cells in the kidney loops, and they can sense how much blood is flowing. They can sense blood pressure. So if there's less blood in those renal arteries, there's going to be less blood pressure. And those juxtaglomerular cells are going to sense that, and they're going to respond by various methods to increase perfusion. Okay, and remember, it doesn't have to be systemic blood pressure. It can be blood pressure solely at the kidneys. So sometimes there's a blockage in one of the renal arteries. It's going to be decreased blood pressure at the renal arteries only. And that whole system, this juxtaglomerular feedback, is going to cause increased blood perfusion throughout the whole body. Now, the lungs is another interesting one. Low oxygen in the lung causes vasoconstriction. So what normally happens in the body? Remember, we just talked about that. Remember, we talked about how low oxygen is going to tell your body, hey, I need more blood. I need more blood that's supplying all this juicy oxygen. But the lungs is totally opposite, and it's going to cause vasodilation. Lung is totally opposite. Low oxygen causes vasoconstriction. And why does this happen? This happens because the lung is for gas exchange. So you want areas of high oxygen. You want blood in the lungs. Blood in the lungs is not carrying much oxygen. Blood in the lungs is there to receive oxygen. So you want blood to go to the areas with high oxygen for optimal gas exchange. So if blood is going to low oxygen areas, it's kind of useless. It's going to go through the low oxygen areas, not going to get a lot of blood. It's going to pass through and go back to the heart. So this is an important distinction. And finally, if we look at skeletal muscles, at rest, there is sympathetic tone, so vasoconstriction will regulate blood flow. But during exercise, the muscles are going to be working hard. They're going to be causing a lot of local metabolites, a lot of energy breakdown, and that's all those local metabolites are basically telling your body, hey, I'm not getting enough oxygen to my muscles. I need more oxygen. I need more blood. So that's going to cause increased blood flow. And the key signaling here is CO2, H+, remember the stuff we talked about already. Then we have potassium, adenosine, and lactate. So you're just going to have to memorize all these. These are pretty useful. Lactate is a especially useful one. So remember, lactate is it's generated from that generation of energy, of generation of ATP. So finally, we have skin. So skin the regulation of blood flow is from the sympathetic system. So sympathetic system causes vasoconstriction, and the reason why this is important is important for regulation of temperature, because blood is very warm and we're hot-blooded creatures. So blood flow is very important. So your brain is gonna regulate that our temperature by increasing or decreasing vasoconstriction. So I mentioned that these stuff up top were regulated by metabolic factors, and this stuff at the bottom, especially the at rest, and this one is regulated by sympathetic tone. Okay, but remember the skeletal muscle is kind of a mix, because at exercise the metabolites are going to be regulating